Kirchhoff's next law. The current through a branch point, also called a junction, is constant. That is, the current into a branch point is equal to the current out of that branch point. Well, what does that mean? Let's look at another circuit. So this circuit, we will have a battery, which is going to be our source of EMF. And let's say this circuit is wired to two resistors that are both in parallel with each other and with the power supply. We will call this resistor 1 and resistor 2. So Kirchhoff's next law says basically the current into a point must be equal to the current out of that point. So let's look at two key points in this circuit. Each one of these components are wired in parallel because they each share the same 2 points in common. So let's just call this point that's attached to the negative terminal of the battery, I'll call that point A. And the point that's attached to the positive terminal of the battery, I'll call point B. Now, I usually like to start my analysis beginning with a battery. So if I begin with the battery, I know potential flows from high to low, or rather, charge will move from high to low potential, positive charge will. What that means is current is going to move in that direction from high to low potential. So if I look at the current in the branch that contains the battery, that current is going to reach a junction. Let's label this current I. Now, when that current reaches that fork, it has the choice of going between two paths. Now, as long as that resistor has some amount of resistance, that current will take each path, but each path in unequal amounts. Most of the current will take the path of the least resistance. So in this case, since both paths at point B have resistances on them, our current is going to split. It's going to split between resistor 1. So I will label that current I1. I1 is not going to be equal to the original current we started with. It's going to be a little bit less. And then the rest of the current is going to go through resistor 2. I'll call that current I2. And if we look at node B, Kirchhoff's law says when we add up all of the currents into node B, it has to sum to all of the currents out of node B. So what this means is the current in the branch that has the battery, is equal to I1, current leaving that node, and I2, another current leaving the node. So they sum. That current forked, and the total current is the same. Current into a point must be equal to current out of that point. And those currents go through resistors 1 and 2, and you know what? They meet back up at point A. And when they meet up at point A, it's the same thing. The sum of the currents into point A must be equal to the sum of the currents leaving point A. So it's the same equation. I1 plus I2 is equal to I. Very simple, very basic, hugely useful.